Wojciech. I'm working as a software engineer at Red Hat, and I'd like to introduce you to the Usbguard project. And I want to actually start with a story of how I got interested so much that I created this tool. And this is probably the oldest reference to a USB-based attack on a company. It's not a black hat attack. It's actually it was actually ordered by a customer from a penetration testing company, and they have told them not to use social media or emails or some of the usual attack vectors into a company. So they have to think about something else, and they actually did something which 3 years later we are calling bad USB, but they did it in a primitive way by modifying the hardware. They took apart a mouse, USB mouse, put inside a USB hub and a USB thumb drive, and connected it to the wire the mouse was using to communicate with the computer. So, and they then wrapped it inside a nice box and gave it to somebody in the company as a gift. So, and naturally, who would think that such a device would do something to a computer? So they connected it and using the usual outrun attack vector, the system actually runs some malware from the device. So you connected a mouse inside your computer, and it suddenly connects to some thumb drive to a system and runs software from that. That's pretty unusual. So, as I said, this is like a primitive way of doing the bad USB attack, which was presented in 2014. So let's show some present to the usual attack vectors which are based on USB. So before we get to explain what bad USB is, the most used attack vector is, as I said, some outrun feature of the attack vector itself, and just connecting a storage device to the computer and relying on the user or on the outrun feature to run the malware. The solution to this is of course, to disable outrun, outrun is a strict feature. Don't do that, and to educate users and not to run software from random devices. So, what can you do as an attacker if somebody educates the users and disables outrun? You can emulate outrun using the USB protocol itself. You can be the device can be the user himself, typing commands and moving the mouse on the computer, but automatically from the device. So that's what I call rogue USB devices. That are devices that USB thumb drives or something that you wouldn't expect that they'll execute some mouse movements or keystrokes on your computer. But the USB protocol actually allows that. It allows that one device can act as multiple devices at once. And actually, these devices you can buy them from eBay for $20. They're called Tinsy USB Drive-by, and there are other small devices available. So another attack vector is the reprogramming of USB devices. That's what we call bad USB today. That's as I explained, modifying the USB mouse by hardware means. This is like modifying in the same way, but by software means. It requires knowing the protocol and how the manufacturer uses to send firmware to the device. So you have to reverse engineer, and it's a bit harder. but it was done by the guys who created the bad USB attack on some commonly used chipsets. And last but not least is the attack vector in the USB drivers itself. So usually, or in Linux, in the Linux kernel, there is nothing that prevents to connect any USB device and have the drivers of the USB device loaded automatically. You can blacklist them, but you have to do it manually and you have to know it beforehand. So what you don't want to load, and if somebody creates a new driver, then it's installed automatically, and you have to add it to the blacklist. And there is actually a CV, quite serious one, from 2013, where there was a heap-based morpho outlaw found in a USB device driver. It was, I think, found by the fuzzing of the USB drivers. And as I heard that there are some non-public ones in the queue. So, if you want to somehow solve it in your company or on your desktop computer, you can use one of two things. You can either completely disable your USB ports, either by BIOS means or by ripping out the connectors or gluing your devices inside the connectors, or you can use actually a Usbguard. So this is like 1 minute how to set up your set up Usbguard in your system. If you are using Fedora, then you can just copy-paste these commands. If you are using Ubuntu or something else, then you have to replace the first command to install actually the packages or compile them if they are not available on your distribution. Using the second line, you can generate a policy for your devices that are connected to your system at the moment the command is executed. So it creates a whitelist for the connected devices, and nothing else will be allowed to connect to the system. If some other device that is not known to the policy or to Usbguard is connected, and if you run the applet, then you get a notification, okay, there is a new device, it has these interfaces, would you want to allow it or not? Or do you want to reject it? So, if you allow it, then what happens is that it will allow the kernel to continue with enumeration of the interfaces on the device and load the interface drivers. Otherwise, it will just block the device node and not touch any code whatsoever in any USB driver, but the USB core driver. So it's the only driver exposed to the USB device. You can also reject the device. That means that it will be the device node will be also removed from the system. Like the kernel won't know about it anymore. You have to disconnect the device and connect it again. So this is the high-level overview of Usbguard. It's a typical Unix daemon which is running all the time and listening for UDF notifications about new connected devices and about changes on the devices. And it relies also on a second feature of the Linux kernel, and that's the Linux USB device authorization feature. It's a boolean flag for allowing the continuation of the USB interface driver loading. So it's thanks to these two features of the kernel, the Usbguard can work as it does. Also, there are optionally the CLI and GUI parts, which you don't have to run, but it's much easier than to interact with the daemon. You don't have to edit the files by yourself and generate the policies and write them. So here are some of the advanced and planned features. The basic functioning of Usbguard is just blacklisting and whitelisting on matching the device attribute that the device exports to the system. That is the list of the requested interfaces that to interact with the system, and some serial numbers, supported protocols, and like basic stuff that the USB specification tells the devices to do. But you can use actually one of these advanced features to make like more complex policies or more intelligent policies. One of them is rule conditions. You can match like the actual the current conditions of the system, like the context of the connected devices. So you can write a rule which like allows a device only if another device is connected or not. It allows you to like check what the time of local time of the system, so you can allow the device if it's working hours or not, and some other basic conditions are implemented. But the list of the conditions is currently expanding, so I'm looking for use cases to implement the others. Currently, I'm working on USB I/O monitoring. That's I/O monitoring like in input and output data and bandwidth. So you can after it's implemented, you can say, okay, I have this thumb drive, and I don't want that people upload the data to the thumb drive. They can read from that, but they cannot upload any data or only small amounts of data which are required for communicating with the device. That's good for the data exfiltration use case. You don't want to have people exfiltrate data from your company on USB devices, but you want to let them use thumb drives to actually distribute some data in the company or on the servers. Another planned feature is device signing. That's actually the original idea for the implementation of the USB kernel authorization feature. But the guy who implemented it, he didn't actually continue in a way to actually implement the device signing. Another thing I like to improve is the UI of the applet. As you can see, it's not really useful to see some numbers here which represent the interfaces that the device wants to communicate with. So ideally, you want to translate these numbers into some human-readable strings to know what the device, what the interface number represents, whether it's a keyboard or mouse or a network card, such a thing. And of course, there are limitations to this solution because the USB, any USB device can be faked and cloned. So if you create a policy that allows a USB keyboard to be connected to a system, then somebody can just take the keyboard, clone it, and he can then reprogram the firmware to insert some automatic keystrokes or something. So all he needs to pass the policy is actually to have the metadata of the device, like the serial number, the vendor ID, the product ID, and you can you don't have to, with some devices, you don't have to steal them. It's just enough to look at them and then look up the information on the manufacturer page. Because usually the USB devices do not export serial numbers. Like thumb drives usually do, but USB keyboards, they are just empty, or they are same for all the products of the company. They're just like 1, 2, 3, 4, just some value. So it's quite hard to actually distinguish two pieces of the same product from each other, from the point of USB card or from the point of the kernel. Another problem is vendor specific devices. The interface types have a hierarchy, a standard hierarchy, and some vendors do not follow this hierarchy. They use the special value that says, okay, this is a vendor specific type, or the vendor specific driver, and you don't know what's in it. So if you have like a bunch of these devices, then it's not a good idea to actually use them in your policies and allow them, because somebody can exploit the fact that it allows this vendor specific thing, and he can create a clone device and attack your system using something else. USB keyboards are especially problematic because, as I said, they don't export serial numbers, so you cannot distinguish them from each other. I think I have some time, so I will show you some example policies. I didn't want to show them before because it looks scary. To have some bunch of lines in a strange language, but actually it's quite easy if you are just a regular notebook user and all you want to use is USB thumb drives. Then you can write this one line in the policy, and it will allow only thumb drives and nothing else. So if somebody inside says thumb drive with a keyboard inside, then it won't be allowed, because the system sees that there are two interfaces on the system, on the device, and this rule only allows only one interface to be on a USB device. Some other examples: you can play Russian roulette with USB devices. It's a special condition that on each evaluation returns like a random true or false with the specified probability. So you insert your device and it's rejected with high probability. This is a CLI usage example. You can, from the command line, you can list the devices, list the rules, or append new rules. So it's quite easy to interact with the daemon that way. Yeah, and that's all.
Thank you, Daniel. So we have a couple of minutes for questions. I have a question first. Does this work on servers as well?
Yes, it does. But you have to run the daemon down. That might not be desired.
Assuming that Usbguard is blocking the device, is there theoretically any room for malicious code to be run lower down on the hardware, sort of below the driver?
Assuming it's blocked, then the only driver that's interacting with the device is actually the USB core driver. And if there is an exploit, then yeah, it will run some malicious code. But I think it's so much exposed, the driver is so much exposed that it's checked like FOSDEM quite regularly. It's a small copy, so I guess. So there's a small probability that there is a bug in the material.
So, you said keyboards are
I can't see the question.
Oh, sorry. So, especially keyboards are lost things since you don't, vendors don't put a serial number on it. Having played with the TNC, you do have something like numeration by default. I mean, it means quite basic. I think it enumerates a couple of devices, right? So, would it be possible to see multiple devices are connected to a certain port?
Yes, yes. That's actually the main use case. If the TNC device would be connected, and like there would be 3 lines, each representing a different interface, this is a keyboard, and the key acts as a keyboard, so this represents the interface to the system. A mouse would be something
So maybe it would be an idea to show the currently accepted devices in this order. Maybe if you have a double already accepted the YubiKey.
If you accept the YubiKey as it is, as you see, then if somebody connects another YubiKey which is another device, or 2 devices at once, it's a completely different device from the point of view of the USB drive.
But I mean, from a user's perspective, I just think, this is
that's why UI to explain what it is and more native
Yes, there can be some communications because points are like the USB instead of
I think it's like on the overall level.
It really smells bad.
Yes. So it's usually like doing something like
I think that there's I can go into this level. Like in the use case, I can only, you can only technically block the device from communicating with some specific driver, but that's all. Once you allow it, then you don't know what the CVs are there with devices.
I'm Toby from GNOME, and last summer we've had an intern during the summer working on the exact problem of blocking USB devices that you don't necessarily want, and I'm glad that we have this system now that she's built which allows us to set it effective to block devices. What we found out very quickly was not the technical, like solving the problem on a technical level, but having the proper policies, as this is a very, difficult thing to achieve or to make work well. So I'm happy to meet you, and I think we should talk. And what I actually wanted to ask is, do you know the status of Linux's capability of blocking interfaces or allowing interfaces only rather than devices?
At this moment, there is the granularity is only on the device now. Right. You cannot if there would be more interfaces, you cannot allow one and block the other. But I guess it's because of the way the drivers are implemented. You can only have like the generic USB core driver, which creates the generic device node with the metadata that the USB protocol needs. But once you get down or up the level, then you would have to modify a lot of the drivers to insert the flag in there.
We have time for one final question up here.
Well, the problem is the USB keyboard and mouse are blocked. I can't click those buttons. So we're going to need a suggestion, some way of entering a password using the device before using the keyboard.
Yes.
Before you actually be connected to the main X server. But that suggests a solution for USB keyboards. Focus keyboards don't have the user's password. So without it integrating to the X server, etc.
The question is like how you can click on or something or write something if you don't have the device or if you don't have a keyboard at all. And that's why it's one of the reasons I implemented the room conditions. You can have, like allow the first keyboard to be connected, but then the condition like tells you that, or tells the USB assistant not to connect any other keyboard. So nobody report or no matter what, no other keyboard. If one is already allowed, then you can like that's like implementable on the policy level using some instructions.
Okay, I think time's up. Thank you, Daniel.